YouTube. The link to the playlist is in our syllabus section of our modules. So if it wasn't fun enough the first time, you can go find that Zoom session. But a lot of people like to watch the videos for coding, because doing the hands-on coding, when you're watching the videos on YouTube, you can pause and really think about what you're doing and kind of stop my screen, where when we're in class, sometimes I'm moving on ahead and you're not quite there. So that's another reason that I like to post those Zoom videos out there for you. It seems like sometimes it's easier to follow along with the video. Okay, so we're talking about sequential data files here. When we looked at those image files and we glitched those image files, you guys saw they're just a sequential data file. A sequential file meaning there is stuff at the beginning, in the middle, and at the end, right? And it's in order. It's sequential. Whenever we looked at those images, we saw each of those pixels had to be in the right order, right, to create that image. If it was out of order, it was glitched, right? We had our pixels all messed up. So it has to be a sequential data file when we're working with a computer file. It's kind of a given. So whenever we're talking about files, we're going to see this kind of icon or symbol on a flowchart. This cylinder just indicates a disk, like a disk drive. So that's usually the symbol that we use. You might see it kind of on its side without the filled in top too, is a disk icon. So we use files all the time when we're programming and just using a computer, right? We don't do anything without files. That's what operating systems are, is file management basic utilities, right? Because that's what we needed operating systems to do, take care of files for us. This presentation itself is Chapter 10 File Basics or Sequential Files.pptx, right? That's the name of the file. When we're working with files, we can save data to files, we can read data from files. We might even use, you guys might have seen way back in the day, a .ini file where you could change the way things worked. But no matter what, when we're working with a data file or a file, we have persistent data. Persistent data meaning it's there after our program is done running. It's there after we restart the computer. So far, all of our programs, we've been doing things where we prompt for something, we type it in, we do some sort of calculation and output it, and that's it. It's over, right? So if we want to run our program, we have to retype all that input data. Well, we know that's not the way it usually works in the real world. In the real world, there's some sort of database or data file that supplies that data and it gets saved, right? So working with files is our first step in being able to keep that data to make it persistent. Now, think about files before we move on. When we're working with a computer, everything is in a file, right? We saw an image is held within a file. It's how we process that file that makes it special, right? The fact that we knew that image file, each character within it indicated a color code for a pixel, we were able to process that file accordingly. We still could have read it in some program. We might not have been able to handle it properly, but it was still just a file. It was special because of the way it was written and the way it was saved. That's how every file is. So if I'm looking at my PowerPoint file, I could read it with a C# program or a Python program, but I might not know how to display it as a PowerPoint because there's special coding built into that file that PowerPoint understands. And so it says, oh, here's a new slide. I'm going to go ahead and read through that stuff. In the same way, a .docx file has encoding built in that Word understands. If I'm looking at a .psd file, Photoshop understands the encoding of that file. It knows how to read it. So there's nothing different about those files physically. They're all exactly just files, files, files. It is the program that reads them and that saves them that makes them into something special, into something different, right? So no matter what kind of file I have, It's just a file sitting out there on disk, just exactly the same as the next file. It's just that the program that uses it knows how to make it into something special. Now, when we're working with programs, we can compile those into machine code, and then that can be something that might be a little different than a data file. No matter what, though, they're still both just files that are sitting out in our operating system folders, and we don't really care whether they're program files or data files. Program files are going to be unreadable to us because they're compiled, so they might look like a bunch of garbage characters, but they're going to be readable by the operating system. Now, here's a data file. This is the kind of file that a programmer spends a lot of time with usually. It might be a database. This one is just in a text file. So if I look at this data file, it kind of looks a lot like an Excel spreadsheet, right? It's rows and columns. Well, every one of the rows is a record. This file is information about students. So it has the student name and some different scores, like test scores for each student. So record 1 is for R. Abrams here, and he has a score of 86, 64, 73, and 84. J. Chavez has these other scores here. So each of these rows is a record about one student. When I look at each record then, each piece of information, each column is a field. It's a little bit of a piece of information. So I have records as the rows, and then each of my columns is a field. And I can process through this data file in my Python program or whatever programming language I want to use to create output or summarize or create averages or whatever we need to do. Now, when we look at data files, I want you to think about these sequential ones versus what we're used to using right now. This is an old VHS tape. When you were using a VHS tape, do you remember using one? No? Some of you do? Well, if you remember, if you don't, think about it. It's a tape. So if you want to watch a certain scene, you couldn't just go directly to that, right? You had to fast forward or rewind that tape to get to that exact spot. And then you could start watching it. So a VHS tape is sequential, like a cassette tape. No matter what I do, I have to fast forward or rewind to get to the right spot. When I look at a DVD or a CD or a hard drive or a solid state drive, those kinds of storage mediums are direct access. I can go directly to a specific spot. So they're much more useful for us in programming, right? So if I want to see J. Chavez's record in that text file, I could go straight to it if it's on a random access device. If it's on a sequential device, like an old tape, I would have to get to that spot before I could actually read that data. So that's important because whenever we're processing files, some of our programming is based on that old physical idea of having this tape that has to be read in sequence. So that's where some of our code requirements come from. So to think about it, the way it'll work in a program, here's a flowchart. We're going to start our program. We have to open our data file, our text file. Once we open the file, we can read a record, that first record in the file. Now, no matter what record it is, we're going to check to see, did we get to the end of the file? If we didn't, then we actually had data in that record that we could process. We'll process that record, read another one, check to see if it was end of file. If not, we'll process the data, read another record, check to see if it's end of file. We'll just keep doing that until we finally get to the end of the file. When we get to the end of the file, then we'll close our file so that someone else can read it, and we'll be done processing through that file. So we have to process it in a sequential manner, just like it's on a VHS tape, because that's the kind of method that was always used. Now, when we think about how we processed our image last time, that C image library let us read that whole image just as one chunk. So we'll find a lot of classes, a lot of libraries that let us do things like that get us away from this sequential access. But if we're reading a text file, our basic way of doing it is going to be a sequential loop like this. So let's look at the Runestone site. And if you can't find it, just type Runestone Academy and search, and it'll find it for you. This one you don't have to be logged on. But I want to go to chapter 11, files. Now while you're getting there, I'm going to bring up File Explorer. File Explorer in Windows 10 looks a little different than it has in the past, and it kind of looks different depending on how things are configured. So if I look at File Explorer here, it looks different than it does on my computer at home. But one thing that I know is always the same is if I click on this PC, I'm going to see all of the devices and hard drives that are associated with my computer. If I look at mine right now, I see the C drive, the operating system stuff that's part of the computer, and then I have my external attached. So that's what that E drive is. Then underneath that, of course, I've got my network locations, the things that were attached by the network. So I could be reading a file from any of these drives, any of these locations. Whenever I look at one of those drives, we know when we drill down into a drive letter, we see all of the folders or directories that are on that drive. Remember that directory is just another name for a folder. It's the older name, and a lot of times if we're programming, they'll refer to it as a directory, just because it's a little bit of an older piece of information. Files have been around since the very beginning, so the file processing programming is some of the basic stuff that's always been around. Now, if I wanted to look further, like I want to look at the users folders, I could go into users and, of course, find mine, and I could just keep drilling down through all of these folders until I finally found a file that I was looking for. As I drill down into all these folders, if I click up here in my address bar, my search bar, it'll show me the actual path name of where I am. So right now, in my Riley RE folder, I'm on the C drive, C:// in the users folder, in the Riley RE folder. And so my path, if you notice, each folder is separated by a backslash. And that's just a standard Windows naming convention. If I went further, I'll go into my music folder, and I clicked up here, I would see that longer path name. Now that's important for a lot of different reasons. First of all, it lets you know exactly where you are. Second of all, it gives you a place that you could copy from. So if I needed to copy this information to get it into my program and make sure I had it exactly right, I could. But I know exactly where I am. So let's go to the Runestone stuff, working with data files. This first little section, they talk about how we need to open a file. Whenever we open a file, we've actually set it aside and kind of reserved it. We've said we're using it, don't let anybody else use it. We had to do this from the very beginning of operating systems to ensure file integrity, right? We can't have more than one person updating a file at the same time, or we would have all sorts of things that were unpredictable. So we can do multiple updates like that with databases and more advanced file types, but not with just a basic text file. So with the basic text file, we have to open it and then we have to close it when we're done. Here we have a lot of different syntax for how to open and close files in Python. Basically, we're going to use the open command, and the file name is going to be a string that is our complete file name. So that would include the C:\/ whatever folder names if we wanted to access a file that was within some other folder. Now the R says that we want to open that file for reading. If we use the open command with a W, it says we want to use that file for writing. So we're going to write output to it. And then we can just close our file whenever we're done. Finding a file on your disk talks about the separators, the path separators that we were just looking at in Windows. Whenever you look at this part in the yellow, notice the / and the /. When we're working with Windows, we're going to see the / is the path separator in between folder names. If we were working with a Mac or a Linux machine, we would see a /. Whenever you look at your keyboard, find the different slashes. So the /, is the / the one beside the shift key, or is it the one above the enter key? If I'm thinking about a /, remember we're leaning forward, so which one is it? One next to the shift key, exactly. So if we're looking at a /, it's going to fall backwards. Which one is it? The one above enter. And so that can be super important to us as programmers, because if we use the wrong /, we could have something not work. Or we could be in a situation where it just adapts and it takes care of it for us. So as time goes on and the programming languages we're working with get smarter and smarter, these things matter less and less. But if we're in a situation where they matter, boy, do they matter. So we want to make sure we've got that / and that / character figured out. Now, they show here that sometimes if we're at a command prompt and we're using a DOS command or a Linux command, we might be in a terminal window on our Mac or in a terminal window on our Linux machine, and we're typing in a command. If we're using Linux, adding options to our command usually involves using a hyphen character followed by the option. So they're showing here that we're going to do this command to list directories on a Linux machine, and we want it to use a long output listing, and we want it to be in reverse order. So passing those optional parameters, we've used a hyphen character. If we're on a Windows machine using a command prompt, it's different. We usually use a / followed by that command. So it can be a little bit confusing if you're switching back and forth between operating systems. And Windows commands have always been super confusing because they use both the / and the / character. So if sometimes you feel like it's making you crazy, that's true. Look at it really, really close and make sure that you're using the appropriate / for where you're at. Because the path name, the file name, is going to have the / in it. And then after the file name, parameter updates to the command will be preceded with a /. Now, in this narrative, again, they mention that our folders are called directories. We like to make it hard. That's from not trying to make it hard for people. A little bit it is. Have you ever run across like arrogant computer people? Sometimes they like to make different names and act like their name is the only name. And that's what happened. They called the directories Bill Gates and all of those Windows people, that was their name. And when Apple came along with a graphical user interface, they said, oh, we're going to call them folders instead. Now we know who's won that one, right? We call them folders all the time. But if you ever see something where they're calling it a directory, it is totally the same exact thing. Now, when we are looking at a path to a file, if it starts with the drive letter, the C:\/ or H:\/, that's an absolute file name. Actually, if it starts with a / or a / at all at the very beginning of the file name, that's an absolute file name. And that means starting at the beginning of the folder chain at the base of the drive letter, find these folders the whole way out. So there's a lot of training available for working with DOS commands and files. So we'll just look at it quickly here. If we are looking for this file, mypythonprogram.py, they give us several different ways that we could access that using relative paths. If we were already in the My Project folder, sitting in the data1.txt file, mypythonprogram.py would be able to, wait, let me back up here. We are writing this program, mypythonprogram.py. If it needs to access data1.txt and it's in the same folder here, it can just use the reference data1.txt because they're in the same folder. If it needs to access data2.txt, mypythonprogram.py needs to go up one folder, that's what the 2 dots are, and then into the My Data folder to find data2.txt. It could use that same path to find data3. Now, if it wants to find data4, it has to go up from the My Project folder into All Projects. That would be 1 ... And then it has to go up into My Files. That's the second ... And then it would be able to navigate into the path Other Files, Extra Data, to find our data4 text file. So fun with files is great, but let's use this file. We've got this file here called qbdata.txt. Let's get it set up for us to use so that we can use it outside of Runestone. I want to go to PyCharm and create some things. Like last time we created that new folder for all of our images stuff. Let's do the same thing with this one. Once it opens here. Get to my right place. I got off from my normal folder here, so we get back to it. There we go. So in my folder that I've been working on this semester, my SP19 folder, I want to create a new folder for this file processing stuff. So I'm going to click on my top folder, SP19, and I want to do File, New Directory, and we're going to call it File Handling. So even PyCharm that's all new in Python, he still calls it a directory. How weird. Okay, so the first thing that I want to create in this file handling folder is going to be a text file. So let's see, I want to do a new file. Let's just try file. And I'm going to name this qbdata.txt. Whenever we're working with text files, we usually name them .txt. That's kind of just a convention, the same as we name Python files .py. We were talking earlier about how that doesn't really matter to anything. It's just a convention. So let's name this qbdata.txt. And I'm going to make sure I got it within my file handling folder. I did. That's where I wanted it. Perfect. Now I'm just going to go to the Runestone Academy site and copy all of the stuff in this middle window, all this data. And then I should just be able to paste it into my qbdata text file. Did you get it okay? Everybody got it? Got some data to work with. Okay, now we're just going to keep that in the same folder just so that accessing it is real simple for our program. So they say to open this file, we would call the open function. If we use a variable named file ref, that variable would hold a reference to our file returned by the open. After we're finished, we can use the close command to close it. So let's create a Python program or script file, and let's put those commands in. I want this Python file to be in my file handling folder. So I'm going to choose new Python file. And I'll call it file handling. So they say we could put in file ref. Let me zoom in. Open, and then our file name. And then after our file name, how we want to open it, for reading or for writing. So let's put some comments in here about what we're doing. File ref will hold a reference to the file. Kind of like a pointer to where it is on disk, right? So the file ref object is our file object. We can just think about it that way. This is our way of accessing that file. Now, if this program runs properly, we don't get any sort of error message. That means that it worked, right? Because we're not doing any output. There's no print statements or anything. So let's just make sure we can run it and get to our file. Oh, I did. It finished with exit code 0. What if I had a typo? What if I left out that T and it couldn't find the file? Let's see. Then I got an error. So if my file handling program wasn't able to open this file properly, I would get some sort of error here, and it says that on your open, the file not found error happened. Which is true, because I put a typo in it. So as long as I have that name all spelled properly, I should get no errors, and it should just finish running, and then I know everything was okay. It took it a second. It's being very slow. It keeps telling me that too. You're working on the network, it might be really, really slow. It is. Okay, click completed as you go through this stuff. Now, whenever we're working with a file, we saw that all of the lines in the file are considered records. So what we can do is process through each of those lines in our file to do whatever we want to them. So let's try and read all of the things in our file. Read each of the lines or records in the file. So I'm going to say for a record in our file ref file, let's print it. So we'll just print that whole record that we read. Now we should get some output here. We should get a row of output for every row of data we have in our file. So let's run this. Sure enough, there we go. And it looks just like our file pretty much, doesn't it? Now, at this point, Python knows that each of these rows is our record. Is that working okay for everybody? Getting output? Stuff good? All right, so what if we wanted Python or our program to be able to speak to each of these different items, data items individually? We would need to split them out. Remember, we used that split command last week. Let's try it again. We'll say our fields equal our a record dot split. That split command, if we didn't put in a parameter, it uses a space, the space character to split. So that should end up giving us all of the different fields in each of our records. So let's change our print statement. Instead of printing out the whole record, let's print out the fields. Now again, we shouldn't see a lot of difference, but we should see those square brackets around each row showing us that Python thinks now each of those rows is an array, a list of items. Let's run it and see. Sure enough, now it has a little bit more data-like, right? It's not as easy to read to us, but it's more ready to read in our program for individual things. So we could look at our program now and we could say the first thing in our fields is the first name. Let's print that instead of everything. Just the index value 0 of our field. And now we're just seeing those first name characters because our split command split the record up into an array. Our array is named fields. Now we can access each of the different entries in our fields array. Let's change our print statement a little bit and let's make it some sort of meaningful data. So each of these data items in our file, get back over here to it. Let me get, where are you? It won't let me get back to it. I finally found it. There it is. This file is about quarterbacks. And so it's got their name and the fact that they're a quarterback, they all say QB. So this came from some other bigger file, right? And they just picked the quarterbacks. It has like some sort of team affiliation and then some other things, statistics, all that great stuff. So if we looked at the headings on the previous page, we would probably find out even more because it tells us what each of those numbers mean. We have completions, attempts, yards, touchdowns. So all of the different data items in our file. So I'm looking at printing out this right here for each quarterback. So we're going to print out their ratings. So I want to change our print statements, and it's going to start out using that QB. And then I want to print out of our fields their first name, their second name, their last name. And then we're going to add a little bit more. Had a rating of, and the last thing that we want to print is subscript or index value 10 of our fields. So now we're going to split it up a little bit more. Let's run it. And now we see each different quarterback and our had a rating of message. And then their number. Why did we not have to add a space in between the first name and the last name? Why does it seem there's like there's extra spaces around this had a rating of message? Do you remember from early Python? You want me to tell you? It's because we're using these commas instead of pluses to concatenate. And if we use the commas when we're using Python in the print statement, it automatically puts a space in between those different fields. So we didn't want to do that through the whole semester, because then it would have been bad for you to switch to another language. Okay, so lots of different things that we could do. Right now, we're using a for loop to process through all of the different rows, all of the different records in our file. We could use a while, and we could actually do a read line statement. Let's create another Python file. And let's call this one file read line. We're going to start out with our file. This time we'll call our file pointer in file. But we still want to open our QB data text file for reading. We're going to declare a variable called line, and we're going to add a row from our input file to that line variable. In this while statement, we can actually say while line. So that means line is not null or nothing. So while we have data for our line, we can split up into our fields. We'll print the same message. Fields index 0, fields index 1. Add a rating of our 10th field. And then we'll read another line. After our while loop is done, we'll close our file. So it's just a little different than that other syntax that we were looking at. This does exactly the same thing. It's just that now we're using the read line command to make that read happen in our file. With our file handling program, our first one, we let Python take care of it with the for loop. And we said, while there's stuff in this file, read it. This time, we're actually doing the read line statement to tell it, read a line from this file. So not much difference. Just notice that it can be done both ways. Run this one and make sure it works. Still have some people typing, so I don't want to run it and mess them up, but try yours. Now here we're reading one line, but we could actually read all of the lines, kind of like we did with our image file. I'm going to put it here before we close our file. And we'll set up my lines equals in file dot read lines. So really small difference. If I choose read lines, now I'm going to have all of the rows. Let's print them. Oops, my lines, not many lines. Now, if you run this, you should see all of these how to ratings of, and then you should see all of our whole entire text file again. Oh, look, it's just, and all it's got is just the one thing. It's like too many things. Do we have to put it in a for loop? Let's try. So I'm going to say, okay, then for each record in my lines, print out that record. So what I have going on here is it's like the file pointer is at the end of the file. We already read it all. So it's not letting me read it again. So I think what I'm going to do is close the file and open it again. And see if that lets me read in all these lines all at once, because I just wanted to show you how to do the read lines, and it's just not letting me. There we go. So that's another important point. When a file is open, we have a current pointer that's just like the index pointer in an array, except that this current pointer is pointing to the location where we are within the file. So as we read through the file, and we've just read record 6, The first, those 5 records that we've already read are kind of like behind us now. We're moving forward. Remember, we're doing that sequential file processing. So since I had already read to the end of the file, I couldn't read the file again. I had to close it and open it again, and then I could read it again. And then I was able to see that the read line statement reads the entire file all in one command. So when we're working with text files, we can spend a lot of time experimenting with them, and they're super powerful. But they are actually just kind of a stepping stone for you guys in your working towards databases, because the majority of program information that's saved nowadays, that's persistent data, is going to be saved in a database, not in a text file like this. We don't see someone, you know, like United Airlines reading a text file with 2 billion entries in it. So this is something that is kind of a stepping stone for you. So be working at it, thinking about, oh, I see how this is happening. I see how this is working. But that's why it's sort of at the end of the semester and not something that you have to spend a whole lot of time about, because you may not use it super often in your programmer world, depending on what you do. So let's do one more practice one to write out a file, and then we'll say that we have file handling experience under our belts. So I'm going to create one new Python file again. And this one I'm going to say is going to be file write. When I started out as a programmer, reading and writing text files was like one of the most important things. So it's interesting how things change. That's good. We like things to change. Otherwise, it's boring. So let's create our input file again. We're going to open our QB data text file. And we're still going to read it. So we're going to use this as our input file. And this is kind of a common scenario. Now, I'm going to go ahead and say that I could read a record. Now, I've read my first record, so I'm going to go into my while loop. And while I can find records, I'm going to split up into fields. And now I'm going to create an output data line. This is going to be built from my fields that I read in. So I'm going to say, well, I want their first name plus, or no, that's their last name, isn't it? Subscript or index value 1, plus a comma, plus their first name. Then we're going to print out that data line with a print command to make sure it looks right. And then we're going to read another record from our input file. And then close our file. Let's put some comments in here. In file is our file reference object. Our physical file name is qbdata.txt. Remember, when we're working with file systems, we have that physical file name. That's what the file is named out there. Yes?
Mine was
Oh, nice. This one?
Yeah, the while loop is just infinite. It will never stop.
Is mine. Let's see. Yes. So click this stop button over here. And let's see what's wrong. Why would that one not work? The other one worked. Let's look at our file read line. While line.
Oh, I think it's because we're missing the line equals in file that read line. Just in file that read line. Do you think that might be it?
To which one?
We had it where it says while line, but then at the end.
Yes, you got it. Right there. It should be record equal. Good job. So it's stuck on that first one. Okay, see if that's better. That should go through better. All right, so we've got all these names. Do you want a space? I do. I'm going to put a space after that comma so that they're not squished up together. Okay, so that's just their names. Let's write that now out to an output file. Now, this is kind of a thing that's a quandary for us as programmers right now, because remember, this file was open for read. So if I wanted to update it, I would kind of have to write a new one, a new version of the file, and then swap names, if that makes sense. So that's what we spend a lot of our time doing as programmers, is trying to figure out how to get files updated, because we can only read them or write them. It's hard to do, you know, a massive update. That's again why we use databases, because then we have that capability without having to worry about it. So in this example, we're going to create a new output file. In our output file, again, we're going to open. In this one, we're going to name qbnames.txt. And instead of using the R parameter to say we're going to read, we're going to use W to say we're going to write. Now, instead of printing this data line that we've built, let's put it to our output file. So we're going to use the write command of our output file. Now, after we write the data line, we have to add a new line control character to our data line so that it goes down to the next line in the file. We've done that a little bit in our Python code, where we wanted to control that new line formatting of our print output, and you guys have done a great job. Remember, that one uses a backslash whenever we're using those control characters like that. Okay, that should be the only thing we need to change, but we do need to add a close to our output file. So with our sequential files, I could add to the end of my QB data if I wanted to update it, but it would be really hard to update one record, one row in the file. I would almost have to create a new output file. So here we're just going to output their names. Let's run this. We didn't get any printed output, but we should see our new QB names text file in our file handling folder. If you double click on that, you should see all of your names there as output. Did it work? Got it? Great job. All right, that's our file handling. We have one option that's a little bit different that we can use that they show us. I'll show you. Because it's so important to close a file, I'm going to delete my QB names. Whoops, I named it wrong anyway, so let me fix that. I'm going to delete this file, my output file. I'm going to uncheck all this safe delete stuff because I just want to delete it. I'm going to correct it to be QB names instead of DB names. And down at the bottom, I'm going to comment out my close because I want to see what will happen if we don't properly close the file. I'm going to run it. It's still finished fine. I have a QB names file. It looks okay. Now, Python handled that all right. Python went ahead and closed that file, but not all programming languages are going to do that successfully for us. So we have to be aware that we always need to close a file. Because of that, and with Python, we could still end up with that file in some sort of weird state where if we tried to read it in another program, we might have some sort of error. Because closing a file is so important, we can use the with statement. The with statement lets us bury an open within it. So this statement says, open mydata.txt as MD would be the file reference name. Everything within the with statement is going to process. And then when the with statement ends, Python will automatically close that file for us. So that's what the with statement does. It says, while I have all this code to execute, keep this file open. But once it's done, once the with statement has reached an end, close the file automatically. To me, it looks like Python did that for us anyways, so that can happen. Sometimes, like I say, we see those advancements where it's just a little bit smarter, a little bit better. Okay, so that's it for our file handling. In a nutshell, you have some examples. Let's put some more comments in there. Open an output file. Read one row or record of the input. And then while we have input, split into fields array. Set up our output. And then we wrote a row to our output file. And then we read the next input. So just a few lines of code. They can definitely take a lot of thinking as to what's going on there. I hope you guys are using your ducks and talking to them about things. And I feel like I need to get you aluminum foil hats. They could really get your brains working. He's got his duck. Okay, then finally, we close our files. We close our input file and close our output file. Now, if you were to take this process and apply it to any programming language, you would need to do the same steps. So that's why it's important for us to just think about those steps. While you guys think about glitching your image and getting started on your final, Let me know if you have any questions. I'm going to try to get to grading. You might have noticed I need to do that. So, try to get you some things graded while you guys are getting some work done. So let me know if you have any questions or problems with anything. Yes, sir?
Something that I would like to help on.
Okay. Let me close this session thing so I don't forget.